Hey guys, so right now we're going to go over the transformations of logarithmic functions. Now for this one, they're pretty similar to the exponential functions. This is the form, the general form that we're going to be looking at because A affects the graph, the base B affects the graph, H and K affect the graph. Now what we're going to be doing, we're always going to be basing it in comparison to the parent function. So the parent function is where we're all starting off. Now in this case, we're going to have g of x is equal to log base b of x. Now b, the tricky part is that b can be different numbers. So there's different types of parent functions depending on what the base is. But these ones all pretty much take the same form whenever b is greater than 1, when it's not a fraction in this case, like between 0 and 1. This one's going to be taking the same form where it's increasing. It's going to be crossing it here at x equals 1. So we're going to be comparing it to that one. If the base changes, we'll go from there, but wanted to go over some of the things that's happening with the effects of the graph when it's transformed. So A, there's three things that it's doing. So if the positive value of A is between 0 and 1, in other words, like 0.25, like 0.3 or 0.5, then it's going to be a vertical compression, means it's going to shrink. It's going to shrink in the vertical sense, okay? So it's going to be wider. Here, if the A value, the positive A value is greater than 1, so just like for example 2, 3, even 1.5, that one, it's going to be vertically stretching and it's going to get taller, okay? So it's going to stretch vertically this way. If your A value is less than 0, in other words, if it's negative, then it's going to reflect across the x-axis, so it's going to be coming downward this way. Your H, it's going to be a horizontal shift. Now, this is where it gets tricky. So if you have an x minus or x plus, it's going to be doing the opposite. So if you're adding a number, it's going to shift to the left. If you're subtracting a number, it's going to shift to the right. Here, the K value is it vertically shifting up or down. So this one, you're following the sign. So if you're adding, you're going to go up. If you're subtracting, you're going to go down. Okay, and then here's an extra bit here that I was talking to you about. If your B, the positive value of B, if it's between 0 and 1, then it's going to be decreasing. So it's going to be kind of like it's reflecting as well. And if your B is greater than 1, then it's going to be increasing. We're going to be analyzing a lot of this one here. That way you guys won't have so much variables thrown at you, okay? So if we go based off of what we're talking about here for this question, based off of these, it's really the H and the K that's being added here. Now, before we do that, I want you guys to know what the parent function is. And the parent function of this case is going to be log of x. And remember, if it's not written, that means your base is 10. So this is a base of 10 as well. So if we're going to compare it to this one, which is pretty much like this graph, this minus 2 and this plus 1 is affecting the graph, okay? And the way that it's affecting is that it's a horizontal shift. If you're adding, it's going to the left. If you're subtracting, it's going to the right. So since we're subtracting, it's going to go to the right 2 units. And since we're adding a 1 on the outside, we're going to go up. So we're going to go to the right and up 1. So if I were to draw this graph here, let's draw this parent function here. We're just sketching it. This is going to be a point that's going to help us figure out how we're going to be transforming it. So since we're going to go to the right, I'm going to move that dot to the right 2 units. So 1, 2. And since we're going up, I'm going to move it up 1 unit. Okay. So that means also what I would do is I would draw this dotted line and move this according to how this is being moved. So if this is moving to the right 2 units, then I'm going to move this vertical asymptote right 2 units. So it's going to be 1, 2. So it's now going to be here. Now, I can't move it up because if I move it up, it's still going to be the same line. So it doesn't really matter about this part here. So I'm going to draw my graph, and here's what the graph looks like. Remember, this one's going to go up here forever. Here, we're going to cross it at this point. So what happened here to this graph, it moved over to the right and moved up. So now this is still your vertical asymptote, okay? So remember, this is moving to the right, and this is moving up, okay? If we take a look at this one, the parent function to this one is f of x is equal to log base 3 of x. So this one, this 3, based on the previous examples of the videos that I'm doing, this base 3 and this base 10 here, it kind of affects on how quickly it's increasing. But we're just sketching it here for now. So if we sketch this graph, it's going to be very similar to this one over here. So it's going to cross it at x equals 1. Okay. So this is the graph of this one here. Now, with all this stuff that's going on, there's a lot of things that's going to happen to the graph. So the 2, if we go back over here, since it's greater than 1, that means it's going to stretch. that means it's going to be skinnier than this one. It's going to be stretched vertically. So this is going to be a vertical stretch. This one here, we were saying that if it's going to be a horizontal shift, and since we're adding, it's going to move to the, if it's adding, we're going to move to the left here, okay? So we're going to move to the left, and then if we're subtracting, we're going to go down, okay? So here it's going to move to the left, and here we're moving down. So let's go ahead and graph that based on that information. So let's start off with this one. So here it's going to move to the left, so it's going to be now here, and it's going to go down to 1, 2. So this dot is now here. Now remember, I was telling you also move over this vertical asymptote so you guys can see what's going on. So instead of being here, we're going to move to the left one. So it's going to be here. So it's going to move down here. Okay, so I can sketch the graph now. However, I want to also make it look skinnier because that 2 is greater than 1. So to make it look more skinny or more vertically stretched, I'm going to make it look just like this. Remember, this is just a sketch. I just want you guys to kind of see more or less of what it would look like, okay? I'm not saying these are parallel or evenly spaced out, but just so you guys can get the gist that these are stretched vertically, okay? So that's what that one does. Okay, this next one here, so this one here, the parent function to this one is g of x is equal to log of x. Remember, it's just base 10. Now here in this case, notice how the parentheses are inside here. That way you guys can know, and I know we've had examples like that before, so if it's inside the parentheses, you guys got to remember that it's part of the horizontal stretch. If it's outside, it's vertical. Okay, so in here, this one is moving to the left. Since we're adding, it's going to move to the left. This right here, if you guys go back to this part here, since A is negative, that means it's going to reflect across the x-axis. Okay, so this is going to be a reflection. This one here, since it's between 0 and 1, the positive value of it, that means it's going to compress, so it's going to look more wider than the parent function. So let's graph the parent function here. We already know that this one's going to cross at x equals 0, so that's what we're going to base it off on, and here's our vertical asymptote. Okay, so we know we're going to move to the left, so it's going to be 1. And then we also know that we're going to reflect, okay, and we're going to be compressing, so this is a vertical compression. So since we have that portion there, we're also going to move the vertical asymptote to the left 2 units. I apologize, this one should be over here, right? So if it's going to move to the left, it's going to be 1, 2. So this is where the dot's at. That's where it's going to cross it. We're also going to move this one here 2 units. So it's going to be 1, 2. So we're going to draw that vertical asymptote here. So normally, if I were just basing it off of this, I would go ahead and graph it here. But since since I have this one here, and this one, I'm going to reflect it. So I'm going to make it come down this way, but I'm also going to make it look wider. So it's going to come in a little bit quicker than this one does here. Okay. So this is the graph of this one here. So what we're doing, this is a reflection, this is a compression, and this is making it move to the left. Okay. This one here, it's a 1/2. Now the 1/2, what this one does, it actually reflects it. So here we're going to graph the parent function. Actually, you know what the parent function is? This is the parent function. Just kind of want to give you guys an idea of what that one looks like. So y, and this is x. So here, we're going to go ahead and graph this, and we're going to still cross it at x equals 1. But we're going to be coming down this way here. Okay, so remember, this one, since the b is between 0 and 1, that means we're going to be decreasing. So it's kind of like a reflection across the x-axis. Okay, this one here, this is where I want you guys to be careful. Notice how there's no parentheses around this one, just like this one here. So since there's no parentheses around both of them, we're assuming that the one closest to the log is the one that's only going to be with the log. The -2 is going to be on the outside. So if we're basing it on the transformations here, this k is the one that's going to be relating to this -2. And the x, there's no -h. Okay, so it's not moving to the left or to the right. So if we graph the parent function, here's the parent function itself. It's just going to be log of x. Okay, base 10. Remember, if it's not written, it's base 10. This one here, it's going to be crossing it at 1. And that's the graph of this parent function. Now, with the -2, what that's going to do, it's going to come down to, so 1, 2. Okay, so notice how the vertical asymptote, it didn't move to the left or to the right. So if we move this down 2, it's still going to be the same line. So what we're doing is we're going to go ahead and graph this, still the same increase of the function itself. So once again, if there's no parentheses, this is the only term that's in the parentheses. The -2 is going to be the k. Here, this one is going to be a parent function of log of x, so also base 10. Now, the difference between this one here and this one here is that this is inside the parentheses and this is not. So this one was making it move down. So since this one's inside the parentheses, it's going to move to the right since we're subtracting. Now, here's going to be the parent function graphed. We're going to have this here. This is the parent function that we're graphing, this one here. Okay, this is your y-axis, this is your x. So if I were to move this one to the right 2 units, it's going to be 1, 2. So this is where it's going to cross it now. And the vertical asymptote is also going to move to the right 2 units. So it's going to be 1, 2. So this is the vertical asymptote. So if I were to graph this, all it's doing is moving to the right 2 units. Okay, so notice how the increasing is increasing at the same pace. And this is the graph of log of x minus 2. And it's in the parentheses.